Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, Chad Gill here. I'm the host of the This is Concrete podcast, where I talk to leaders in facilities management, architecture, contracting, and more. Workforce Recon is a sponsor of this podcast. Recon is a project tracking software that connects the office to the field crews. Built with a field-first mentality and developed by contractors for contractors, it includes time and asset tracking, messaging, job documentation, and scheduling all in one place, so you can see what's going on today in the field in real time. So if you're tired of finding out what happened days later, check us out at workforcerecon.com. See your operation in real time. Our other sponsor is Laminin Coach. Laminin is a business coaching company with a focus on contractors in and around construction. We not only help proposing solutions and methods, but we implement them in your business as well. After all, good ideas are not useful until they're implemented. So if you're ready to elevate your business, visit us at laminincoach.com and see our full range of services. So joining me today is Doug Krause, the president of RUTE Foundation Systems. He produces and delivers the most efficient, sustainable structural foundation systems for wind and solar industries. And through hard work and impeccable safety practices, they are instrumental in the effort to lower the cost of clean energy and reduce CO2. Doug was into precast concrete in the 2000s and then wind power, and brought the first precast post-tensioned wind tower foundation to the industry in 2018. From climbing in Chile to a job fishing in Alaska and high-tension cable rigging in Spain, these are all the seeds of his work today in concrete and wind energy. So Doug, I don't know how much of that I mispronounced, so I apologize if any of it, but welcome to the show, and I appreciate you coming on.
Yeah, thanks, Chad. I appreciate it. This is my first podcast, and you got all that mouthful of stuff absolutely correct. We are RUTE, so we're good.
Perfect. Climbing in Chile, fishing in Alaska, that job fishing in Alaska sounds like a hard job. I had a friend did that, and that was by no means not physically demanding.
Yeah. No, it made me who I am. That was the hardest part. And the funny part about that is the easiest part is actually doing the job. People hear about it being a hard job. The hard part is being awake for basically 7 days straight and being cold and hungry and tired and being able to be functional. So the actual job itself, run around with a bucket tied up over here, gaff a fish, gut it. That it really is the mental part of, working long hours, being wet, cold, and tired forever. And a lot of people, you kind of lose them mentally.
Yeah, I imagine there's a lot of comfort that comes later in life when you're like, well, this is bad, but it doesn't suck nearly as much as that one time on a fishing boat in Alaska.
Yeah. Honestly, that's kind of in our DNA and RUTE. That's how we look. In fact, I just hired a commercial fisherman for a recent job, and it's just so night and day the difference between a person that shows up and it has it in their head that you're not being paid just to show up and stand over there. On a boat, you make zero money unless you catch fish and then get the fish back to port and sell them. That's the first time you'd ever get the sniff of a paycheck.
Right.
So we're going to try and build a company with RUTE that it's not all fishermen, obviously, but crews that can take command of the safety, quality, production, but also work as a crew and kind of manage themselves for their safety first, but get the production to where you're kind of redefining what's happening in the industry.
Yeah, it's kind of the Jocko Willett extreme ownership type model. It's like everybody knows their job and owns their job.
Yeah.
Hands down. So my early industry knowledge was through nuclear power, and then my first real exposure to wind turbines and stuff like that was to see them in I was driving from Denver to Cheyenne, Wyoming. And I was amazed at the sheer size of these windmills. They are tremendous. Is wind and solar, is that really a massive potential energy source for us, or is it just kind of a government play for environmentalism, or is it real?
Yeah, it was a good question, and you'd be surprised even in our industry. Uh, you still get people with biases that are out of tune with what I would just call the math. And so the math is pretty simple. If you can make electricity for 3 cents a kilowatt hour, somebody's going to buy it. So that's the basics, you know. So if it costs, 6 or 7 cents per kilowatt hour to generate with coal or nuclear, um, that has the benefit of not being intermittent, the sun's shining or the wind's blowing. But if you went down to the market and somebody had some electricity there, but it was only there from a certain part of the day, well, you'd probably show up there at that part of the day to buy it for half price. So that's kind of what's driving the planet towards um, utilizing that resource and just growing it so fast. It's just so much cheaper.
Are you limited in the ability to store it? Like I know, like California, they create a tremendous amount of solar for a short period of time, but it's not necessarily during the peak hours or available to, I mean, I guess that you have to have a massive battery. Is something later down the road going to have to be a massive storage facility or something?
Again, a good question. Until we get to like what they call like penetration, so like 60% intermittent penetration, normally you don't have too much of a problem. In other words, you don't have to run around and freak out if there's like 10% intermittent power on the grid. The grid is of itself a battery. And then if you start connecting the various regional grids together, you got even a bigger battery. You don't want to ship all your sunlight in California out to Rhode Island to get to for their evening load, but that's kind of an extreme. So there is the more interconnected you get. So like when Eisenhower built out the federal highway system, they had a plan, they had a grid, and they just did it. And we could build multi-trillion dollar, free enterprise system that would fill up that grid with commerce instead of trucking or driving to vacations and whatnot. It would just be people plugging in power plants where the demand was most suited and supply was most suited. So we just don't have that right now. So some of the issues that we have with balancing out wind and solar, it just happens to be that there's not a adequate, transmission system.
Yeah, to get in, and that's, you hear a lot about that, saying that our grid is the weak link right now. When they talk about that, are you talking about management of grid, or are you talking about literal lines in the air or lines on the ground?
A good question again, and that's the other thing. When someone talks about the problem at hand, a lot of times it's, they just say transmission, and they might have heard about that. But if you just go back to the mathematics, um, it doesn't cost that much to move electricity on a wire. So if the wire was built, then you would find the marketplace would take advantage of that just because it's so cheap to move energized electrons. It's hard to build transmission lines because you're dealing with federal issues. So, for whatever reason, all that permitting stuff takes forever. And an interesting example of like Texas, uh, George W. Bush made at the time this giant explosion of wind power happen. And I think he was just happened to be sitting in the chair when it happened because wind power got cheap. There were I would say, non-rules in place to let it happen. All of a sudden it filled up. And if you go back in like the wind press or energy, like utility dive, all these industry rags on utilization of energy, you'd see issues like, oh, Texas just tapped out their whole entire ERCOT transmission system. Well, we can't build, there's no more room for intermittent wind power. And they published and republished that identical story like 5 times. And in ERCOT in Texas, they can just build stuff fast. So I think they put like, it's somewhere around like $30 billion into transmission lines, and they would go up overnight.
Yeah, I
Like,
mean, it's not like building a building. I mean, your poles and wires. I mean, it's not as easy as that, but it's not as hard either.
if somebody wants to put a transmission line up, you're correct. You got a bunch of galvanized steel stuff, you hang it up, you tow some cable, and now you have it just a giant extension cord. So the capacity in ERCOT, Texas went during George Bush's, say, run, uh, I think 12 gigawatts of wind or something like that. And I think they're up to 80 or just something absolutely crazy. So first time they said that you can't build out the transmission line, they've quintupled that amount. So somewhere along the lines, they built all that, those billions of dollars of transmission lines. In a regular U.S. where you've got federal land use issues, uh, they didn't quintuple the transmission capacity like they did in Texas. They've basically done triple zero, whatever, zero, maybe a couple transmission lines, but people decide that it's impossible to build a transmission line and then ignore the fact that Texas multiplied theirs 5 times and with nobody paying attention.
That's right. So, but yeah, and, that's everything's bigger in Texas, right? So
Yeah,
they
yeah,
transmission.
yeah,
So that's got to be frustrating. I mean, that's an uphill battle. I mean, you would think on one side, the press is all with you in the idea that environmentally friendly new renewable energy, but then it's against you in it's like they're hell bent on the idea that we should definitely generate power that way. We just can't move it. So I guess every house needs a windmill sit on top of it in their mind.
yeah, yeah, yeah. I love the energy industry, both, the whole deal, gas, nuclear. I'm definitely not Mr. Coal at all. I think coal should just go away. Not for any other reason than, just gas is so much better than coal, and nuclear is better than both. And, you know, uh, you just don't need to, I mean, burning coal, like, I'm sorry, I'm just not into that one. If you think about what you have to do to burn coal, third of the weight or something like that, or 40% of the weight just ends up as dust.
It's
So,
yeah, I mean, I'm a big fan of nuclear power. I mean, hands down. I mean, nuclear power, a guy explained to me is that he said nuclear power, that's your baseline power. It's like how much power do you need at the lowest point in your day? That's what
yeah,
you use a nuke plant for. And then you have gas turbines or something else that handles your peaks. But nuke is just all day, every day. Because it's hard to, you don't just spin the thermostat on your reactor and heat it up a little more. But yeah, you're right. Gas power and stuff like that. And yeah, coal definitely has some issues. So how
yeah,
do so you're doing footings, your
yeah.
modular footings for wind and solar? I mean, wind, hands down, that's a big sail sitting up in the air and it's way up there. I got to imagine that's a huge foundation that you're putting in place.
Yeah. So when we formed RUTE, all we had was a single product, what we call RUTE Foundation. It's just a box girder bridge technology brought to the wind industry. And I don't know if you're familiar with what a box girder looks like for a bridge.
Yeah, yeah, it's hollow and
Yeah.
and so reinforced.
Yep. And then they're all post tension together. So they do put an epoxy. Um, uh, they put epoxy in the joints, but they're not structural epoxy. Just there to keep salt out of the inside for corrosion. But effectively, a bridge, and this is all over the world. Probably like 90% of bridges now are what they call segmental. So they precast concrete this 8 foot, 10 foot section of it. Might be like 50 feet across would be the width of your lane, and then they fly them into position, and then they just squeeze them together with this first a temporary bolt to hold in place, but at the end of the day, you have a what they call a post tension tendon, a whole bunch of them, that just puts the squeeze on the whole system. And the reason why the world's gone to segmental, what we call segmental precast, like that, is because concrete loves to be in compression, and steel's really good at compression. So that mixture translates over to wind really well, because you've got this giant tower that wants to tip over, and down on the bottom, you've got a foundation made of concrete. And the most efficient utilization of concrete is the same way the bridge dudes do it, which is you've got a structure that isn't bending. On the downwind side, it bends up. On the upwind side, it bends down due to the ballast on top of the soil. And so really, if you design something that's designed to take that bending load most efficiently, you find that a hollow structure with post tensioning is ideal. So we came up with one, we built one, and we built one so far. We got a lot of, we issue a lot of quotations. The reason why we haven't blasted off yet is just because the cost. So it still is cheaper to back up to a hole and dump concrete in it, bury it, and hit the road. But long term, what we're seeing now is an interest from the owners for a longer term perspective. Wind industry is no longer this nascent thing where it's more of an idea and people are, trying to cash in on tax credits. That kind of era is gone. Now it's a time of, utility scale solutions for long term, consumption of electricity. So that's what we're seeing right now. And the defining milestone, you might call it, would be what you'd call a life cycle. So utility scale wind started about 2002, 4. The life cycle of machines, 20 years. We're just kind of right now in that point where we're entering what you might call adolescence, or the first step of maturity.
Oh. And that makes, you think of it as, in the simplest of forms, it's a really big Christmas tree stand.
Yeah.
It's huge. They're really, and then are they buried, or are they sit on top, or how do they, where do you, I'm assuming they're down in the ground some. I was looking at the photos on your website. They're amazing.
Yeah, you can walk around inside ours. Like, you climb down, they're 12 feet underground.
Man.
They're big.
You need to rent them out. That's an additional revenue stream. You can Airbnb the inside of those things or something.
we joked about that a lot. It'd be like a lighthouse tender. You have people living down inside those things.
Yeah, exactly. That would be probably easier to sell a person the view of the coast than the view of the plane.
Yeah.
Yeah. Where are you using them in solar? Because you feel like solar, the things I'm used to seeing are the big solar fields. Just acres and acres of panels.
Okay, there's a bit of an irony here, which we kind of just fell into out of just weird happenstance. But what we use for the footings for our solar product is the chopped up blades of a wind tower.
Really?
Yeah. Yeah. I can show you. Actually, I picked my laptop up there. I've got a box that Vestas sent me from Iowa. So that's where their facility is that mulches wind tower blades up.
Why? I'm just going to ask it. Why are we mulching up wind tower blades?
Have you been following any of the controversy about all that?
I'm not sure. I am reluctant to even say what I think I know about wind tower blades, because I don't know. For all I know, I saw it written on a bathroom stall. I don't know that these are reliable facts per se, but I know they're way bigger than I thought they were, and that they're very hard. And then you see the videos where they're just burying them. And,
well, I don't think nobody's burying them anymore. There was a couple occasions of that, and then the industry decided that, you know, the, again, that comes back to the math. You do the math on how many these are just gigantic, the blades. So once you get done with utilizing them one time, you got 13 tons of fiberglass, I think, per blade, or 26 tons. It's a whole lot of tonnage of fiberglass. And
So
then,
it's
of
a
course,
fiberglass blade, and they're 100 and some feet long or something. I mean,
yeah,
how long?
I mean, the ones that they're decommissioning now, uh, 60 meters or something, but everything nowadays, those blades are more in the neighborhood of like a football field, a little over a football field.
One blade, and there's three blades on a
Three
turbine.
blades. Yeah. And then those big guys are, I don't know how, it's tens of tons of fiberglass per blade. So then what do you do with all that fiberglass? Because the steel tower, the foundation, the electrical wires or you conduit that collects all the electricity and takes it to a substation. If you think about a regular electrical system, you know, everyone's in a house. If you're in a house that's 56 years old, nobody's thinking about, oh shit, I got to pull all the copper out of my house. You know, it lasts for a long, long time.
Sure.
And with a wind plant, once you build it and you build that underground electric system, you might as well utilize it for more than 20 years. Steel tower is good. The only thing that really fatigues out would be your fiberglass. So you will have to change out the blades periodically.
Really?
Yeah. Just like a nuke deal with probably your turbine. What are your little deals on your turbine? Those little
Yeah,
flakes?
the fins. Yeah,
Fins, yeah. I'm
yeah,
guessing that you guys change those out regularly.
yeah. I mean, you're gonna have to replace those. My work was always in the steel heat exchangers, and the problem with those is you start out with 15,000 tubes, and you just plug them as you go. So you might finish your plant with 10,000 tubes.
Oh, no kidding. Oh, because they can't add and subtract or
Yeah, you can't replace a tube
hard.
of a steam generator. The steam generator replacement, you can replace the whole thing, which is amazing. But
Yeah.
yeah, massive cranes and stuff. But so these turbine blades, so you're, I guess you're mulching these up, and you're mulching up fiberglass, and then are you recasting that inside of the concrete? Is that what you're doing, or is it not concrete?
Yeah, it's not concrete. So the RUTE Sun Tracker is a solar. The thing that we have in common uh, is both the solar and wind division. They supply what you'd call the balance of structural system to the energy producer. So our customers are selling electricity to the markets, and they need to, and the ones that are selling wind or solar produced electricity, they buy these generators, whether it's a solar panel or a wind tower, and then they need something to hold that thing up. So the tower is held up by a giant concrete footing. The solar panels are held up by what we call a tracking or racking system. And our addition to the world of solar is what we call pasture voltaics. So uh, it's meant for gigantic projects and meant for cattle pastures or cattle rangeland. And it's no concrete at all. There's zero concrete. So it's all steel cables. So the cables comes into play. We use cables in both the systems. But then for the footing, because we're using cables to hold everything together, tension, the footing doesn't have to do a whole lot of work. So it's not like a thing wants to tip over and it's being held together by the ground. The thing that what's holding the panels in place are the cable trellis system, and the footing is just like just needs to keep a pretty moderate amount of earth pressure down there to stay put. So what we figured out really quick was that if we were to scale this up, we're going to need a lot of footings, like millions of them, and humping 300-pound pieces of concrete around precast, for example, or any other footing alternative would be better if that thing was light. So, and I mean, if you had to put your house or your garage footing on a piece of used fiberglass, maybe that's not ideal because the footing is generally sized for the load. And the load in this case, you just have to have a bigger piece of reused fiberglass. In our case, it's just a de minimis amount of force that even a small footing, if it's light, it just makes it very much more installable. So we can build a factory next to a fiberglass recycling plant, stack these blocks on a flatbed and get them to a site way cheaper than you'd otherwise be able to do it with local concrete.
Wow. It's kind of the idea of like the precast pads you see for boxes and panels and stuff like that. I mean, they're fiberglass because they just need to cover a footprint. It's not
Oh, you mean like I didn't. What are you referring to though?
like the pads you see. I have a backup generator. My backup generator sits on it. It's not a concrete pad. It's just a fiber reinforced. I guess it's a fiberglass pad because it needs a footprint.
Yeah.
Yeah.
I didn't even know about that. So I know the pad mount transformer would be a glass box, but then you're saying the thing it actually sits on, somebody's making a modular, lightweight.
Yeah, but I mean, they're like backup generators. This is small generators. This is residential backup generator. So
Yeah.
it's not real heavy, and it's just needs a pad to sit on. Like you said, it needs to be rigid, but it doesn't have to hold a tremendous lot.
Yeah. Yeah.
So that makes sense. So what you said the main thing is just the cost right now for the precast concrete of just being able to compete against, because you have to form it and you have to make them and you got to deliver them and install them, as opposed to, are you competing against something that has that same three-dimensional shape, or are you competing against a poured flat foundation?
The shape the shape and profile is nearly identical. So what we'd call, if you're a foundation engineer, you would call it inverted T gravity foundation. So both the conventional, like pretty much 99% of everything that's ever gone on the ground almost anywhere on the planet is what they call a spread foundation. It's really not a spread foundation, it's a inverted gravity T. So it does spread out far enough to manage that bending load.
Yeah,
And so
it has that kind of triangular shape profile so that you got support from the rib.
Yep.
So when they're pouring them solid.
Yep. Another problem there. Yeah.
That's a lot of concrete.
Yeah. They're getting up to be around 800 yards now per foundation.
That's which, I mean, concrete, I don't know, gosh, concrete, I feel like it's a couple $100 a yard now, but it might be $150 a yard at that level, or maybe $120 a yard.
No, they when they procure those for wind sites, they do it all in. So it's like the supplier, puts it in the hole. So the conveyor or pump, testing, batch plant on site, all the whole thing, and usually coming in around 200-ish per yard. Varies a lot by region, but yeah, 200 would probably be all in 250 maybe.
Yeah, that's a lot of concrete.
Yeah.
It goes, I mean, but I would think that's some intricate forming too.
Now I was talking about this, they're conventional. For us, box girder, yeah, for them it's a piece of cake. I mean, there's no they have a former on the pedestal, but essentially there's not a whole lot of forming. A lot of, you tie a big heavy cage in the hole.
Mm-hmm.
And then what we would do is we'd set up our mobile precast facility off-site. We usually find a local quarry that's got the right, the right aggregates, hardness usually what we're looking for. We're high strength, so we got to go high strength concrete. And I know this is concrete, so if you want to get into high strength and precasting, it's a deep subject.
And you can make some exceptionally strong concrete in those conditions. It's incredible.
Yeah.
But you're mobile precast. You're precasting somewhere close to the job site. Then you're not precasting regionally and then shipping.
Correct. Yeah. Now, what do I know? We've built one. Nor the conventional wisdom would be a precaster or a general contractor would typically think there's a regional precaster that would be a perfect match. And I used to be in precast, so we used to use all the big names to supply the vaults. Um, uh, but if you're going to do high strength box girders for a wind farm, you got a couple problems. One, the castings got to be gigantic. So right off the bat, your transportation puts you, at a disadvantage. The other thing is mix in high strength, but also durable. It's a really special case, and it's hard to utilize the batching facilities of some legacy type of deal because it's different. You basically have to set up a whole different batch line. And on top of that, you got to basically go round the clock with a crew of 30 people for 3-4 months. And so that's just a whole nother plant. So that's why it's not a good match to have existing precast operations to piggyback on. That doesn't work. So then we're not making this up. I mean, the wind industry's got concrete towers. There's enough demand for concrete towers. You see how what they typically do is kind of this model where you get close to the job site and set up a mini factory.
Because you're not going to build one windmill, you're going to build a farm.
Yeah. Yeah. And that's if somebody was to say, how come you've only done one so far instead of a whole wind farm, where there is that kind of that, I forget what they call it. There's the gap, the Death Valley, where you've got you have to capitalize the operation first before you can get the purchase order.
Yeah.
So that we've never invested the $1.5 million into the form system yet because the size of the towers are all over the map. And so you build a form system for whatever tower, but you don't get you get a purchase order for a different tower. And your customers looking for, they've only got a couple suppliers and they can't tell you what tower size they're going to go with because that's strategic intel for them till essentially a couple months before they finance. So we would need to have these, $2 million form systems built in order to capitalize on that opportunity.
Yeah, it's a long lead. Just on ready to start. And then you got to.
Yeah. And then the IRA bill, what it did is I know it's super controversial, all that money thrown at the wind and solar people. But on the one hand, anybody who complains about that is correct. It is a ton of taxpayer money. Like the IRA bill, it is nuts. It is absolute nuts. It's nothing like even back in the day when the wind industry was really more on a sink or swim on the subsidies. Now we could swim all day long without a subsidy, but the IRA bill really put everything on hyperdrive. So the demand is off the charts. The thing it did is it said everybody's got to be on prevailing wage. So it kind of carved out some of that taxpayer money goes to higher higher returns on the labor investment, which is cool. And then the other I forgot what I was going to say there about the other thing the IRA regarding
competition and just the volume of money going at it. I mean, it's a lot of money.
Yeah.
And
yeah.
Sometimes that's good and sometimes that's bad.
Oh, so what I was going to say is kind of actually cool is, digging into the weeds of how these markets operate and stuff. Well, if all of a sudden you juice a sector and you just say, create demand off the charts, what happens is the supplier's like, oh, geez, I just have to make lots of these things. So rather than the OEMs trying to focus in on all the intricacies of each different customer, what type of generation, regionally, all that kind of stuff, because of the IRA bill, they're both real or the main suppliers of turbines, which is about half or 60% of the cost of that entire electricity package. They're realizing that they're going to have to just get their plants on 3 shifts and make the same thing as much as possible. So then they turn around and tell everybody, look, for the next 10 years while this IRA bill is hot and heavy, we're just going to make these things. That's it. Kind of an interesting aside. And so that makes it easy for us because now we only need 2 form sets.
But then you come back to the idea is like suddenly extreme funding actually cut innovation because necessity is the mother of innovation, and there's plenty of money. And they're like, hey, if it's a little less efficient, we don't really care because we can make them faster.
Yeah.
And they're not wrong. I mean, it's a business decision.
And that there is a good point there. If I put my industrial engineering hat on, I mainly do structural mechanical stuff but we did have to design a plant. So in terms of overall efficiency, there's so much stuff for the wind industry to work on, not just like the efficiency of a wind farm with 3 megawatt machines instead of say 5. That part's already been figured out. Like those wind turbines are close to like 95% efficient.
Wow.
It sounds nuts. Yeah. It sounds absolutely there's a formula for how much energy you can extract from a wind mass. And I think there's a name for it. I forget what it's called, but it's like 57%, because you have to leave that other 40% of energy in the air mass. Otherwise, you'd kind of create a cliff.
Right.
So it's some profound physics stuff, but they figured it out in theory. And then within, I think somewhere around 2004 or 6, those machines were getting right up to that 57%. It's really fascinating. I mean, if you're into physics stuff.
Yeah. And then, a second row turbine versus a front row turbine versus a third row turbine and the spacing and it's I love the little things that people just I mean, I used to tell people, you don't understand how absolutely amazing it is that you can plug something into your wall and you've got somewhere around 120 volts or 110.
Yeah.
110 volts. I mean, like, you just understand how hard that is to make happen. So that's fantastic. Well, Doug, this has been great, man. I really appreciate it, and I hope this continues to grow for you. And I'll keep checking Airbnb for one of those. Although I don't know if my wife would go for that.
What's that? Oh, yeah.
But you may be solving an energy and a homeless problem all in one shot. You never know.
Yeah.
You might be able to adjust some of your labor shortage too.
What part of the world are you in right now?
I'm in Virginia.
Virginia?
Yeah, just outside of Richmond. And where are you?
I'm in Portland, Oregon.
Absolutely. Yeah, it's there. You've still got half a day left.
Yeah, it's 2:00. Yeah. And our biggest market for our solar stuff is down in the Southeast. And, we've started, I guess once we build this first one, we build them on cattle ranches. And we've gotten a couple calls from Southeast ranchers to bring our product down there. But it's been a challenge so far as limited resources and reaching out to Southeast ranch land. But that's essentially, if you just went back to the math, that is our best market.
Yeah, I mean, I would have thought coastal, but maybe it's just not. I mean, not a lot of people want to put it on that coast because you're worried about the view of the water and that kind of thing.
Yeah. Well, for the solar stuff, I'm referring to the solar part. We don't do much siting like for the wind foundations. That's just if customer calls us up, we give them a quote. Could be wherever, and if it's the higher the volume project, the lower cost we can get, because the setup cost is so high.
Oh
And
yeah, if you're building a batch plant and a precast plant.
Yeah.
That's
Yeah.
daunting.
It's all mobile. It's about 35% of cost of goods for a small project, and that gets you that puts you over a competitive price. But then when you get up to 100, now all of a sudden you're cheaper.
Yeah, I had a mentor one time, and he always we were big into automation and CNC work, stuff like that, and we were doing CNC machining. He was like, "Yeah, that first bolt costs you a lot because the rest of them are damn near free."
Yeah.
That's true. Oh, well, I wish you luck with it, and yeah, it's good to meet somebody that's getting, and I hope you're getting some of that money coming for it, and I hope this thing grows for you. It's a very interesting industry to be in. I'm sure it's challenging at the same time.
Yeah, it's exciting times.
Well, thank you so much, and look forward to catching up with you again here and see where we are in a year or two.
All right, thanks, John.
Thank you.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.